Hello, so we're into the third question of the Havant Sixth Form College Differential Equations test. Still first order, but this time involving a substitution. The substitution will always be given to us. In this case, it's unrealistic to expect you to know all the different kind of little tricks and cases that we would have to know for all this. So you're always given the substitution. So y equals to vx, we're going to use the product rule. Nice and straightforward. dy by dx times by the v differentiated is dv by dx times by the x. The x differentiated is 1 times by the v, so that's plus v. Okay, so that's we're going to substitute that into the formula here, which I'm going to just write out now. And then we're going to actually just blitz it and put it into there. So as I say, we're going to put this expression into there. I also note that our final equation eliminates y, kind of swaps out y for v. So we're going to substitute y equals to vx into the appropriate place here as well, into there and into there. Okay, so that gives us x dy by dx. Oh no, that's just writing the same thing out. That's just right, x squared dy by dx, which is this expression from above here. So we get x dv by dx plus v equals, now we've got x squared minus x times y, so x times vx, plus y squared, which is v squared x squared. Right, now notice that there's some cancelling of x squareds going on here. I forgot to write the x squared there, but we can see it cancels. X squared there cancels with x squared there. So that gives us x dv by dx plus v equals to, that's going to give us 1 minus v plus v squared. Now we've already got a v over here, so we'll take that over there. That gives us x dv by dx. I'm sure you can see what's happening now, but I'll write it out anyway. Plus v squared, which gives us x dv by dx equals to what v minus 1 squared as required. So that's the first part of the question done, the substitution. Okay, now the second part, for part B. Okay, so it's a case of just following the instructions really. Once we're given a substitution, just put it in and away we go. Right, now this is a separating variables case when we get to here. This is a separating variables case because you can see what's going to happen. We're going to have 1 over v minus 1 squared here. dv is equal to integral of 1 over x dx. Okay, that student a couple of days ago was surprised that it might be asked to separate the variables because obviously it's on C4. Don't be surprised, as often as not in these cases it's going to be separating the variables other than the other one would be integrating factor, but really it's just as likely to be this. So now we've got this integrated. We really hope I don't have to, that should be reasonably fluent to get this ln x plus c. Okay. Right, so I'm going to do a little swapping around. I'm going to reciprocate, I'm going to find a reciprocal of all of this stuff here. If I, hopefully this isn't too much of an active faith for us here. Ln x plus, oh, got the wrong way around. That would be, because it would be wrong. 1 minus v 1 minus v is equal to ln x plus c. I've changed the sign and basically done the reciprocal on both sides. Okay, so that gives me, because it does want it y in terms of vx, but I've chosen to do a bit of tidying before I've substituted the y back. So we've got v is equal to 1 minus 1 over ln x plus c. Okay, now v, we will note, is equal to y over x. So we have y over x is equal to 1 minus 1 over ln x plus c. So our general solution is y equals x minus x over ln x plus c. That's our general solution, but we are given some information that enables us to give the particular solution here and therefore work out c. So we've got y equals 2, x equals to 1, so we have 2 is equal to 1 minus 1 over ln 1, which is 0, plus c. Okay, so that will, when we play around with that, we get 1 is equal to minus 1 over c, so that gives us that c equals minus 1, and here we go, we're done. We just rewrite the equation now with the value of c in which we have just found. Okay, going through the motions there, not too bad, is it? I think you'll agree. It's always easy, I suppose, to when you see it done, to kind of think, why didn't I do that? But a lot of this is practice. And so if you did this, if you tried this yourself and found yourself struggling, it's just practice, and you know, you'll get there. Okay, so that's 7 minutes. We're done on a 12-mark question. So that would be pretty good if we could have that level of fluency. I do feel I might have rushed it a little bit, but we're done and we're on to the next question. Thanks.